Welcome to day 5, the first lesson in the next phase of the randomizer project. Day 5 is all about creating and implementing the game of Boggle. We'll be creating a Boggle die, a Boggle board to contain those dice, and then a Boggle runner, and finally a full graphical user interface that will allow us to actually play the game of Boggle. But we're going to need to start by reviewing the world that we've created so far. So let's begin by talking about the randomizer interface. In the randomizer interface, we listed methods that we wanted all randomizers to have. The first of those methods was getPossibleOutcomes, which returns an integer value that tells us how many possible ways that randomizer can generate a value. For example, a 6-sided die can return 6 possible outcomes. A deck of cards could have 52 possible outcomes. Then we had a getCurrentValue method, and that method would give us the value of the randomizer. In the case of a 6-sided die, that would be like 1 through 6. In the case of a roulette wheel, it would be the number on the wheel, etc. Then we had and by the way, this value is most often used for programming purposes, so it may not be a meaningful number depending upon our randomizer. For example, if our randomizer was a coin, what would be the value of a heads versus a tails? Well, sometimes we have to just simply arbitrarily assign it a value. And then we have the getCurrentFace method, which returns the showing face of our randomizer in the form of a string. Next, we have what is arguably the most important method for a randomizer, which is the randomize method itself. Now notice that this is an interface, and therefore none of these methods have been defined because an interface doesn't have any codes. It is simply a list of methods that we must have if we're going to be considered to be a randomizer. So what class did we choose to have implement our interface? We started with an abstract randomizer that implements the randomizer interface. That means all of the methods listed in the interface must be listed in this class somewhere. So our first method that must be listed was getPossibleOutcomes. But we said for an abstract randomizer, we don't really know how many outcomes there are going to be, and so we marked that as abstract, which allowed us to leave the method undefined, which is what an abstract class is. It's a class with some methods that are left undefined. Those methods are marked with the keyword abstract. Then we said, okay, we're going to have a method that gets the current value. Well, for most randomizers, the current value can be said to be the side that is showing, that is facing up. Okay, so we simply return that as an integer value, but in order to store that value, we need to have an instance variable, side up. So we created that instance variable. Instance variables are always marked with the keyword private. Next, we had to have a method that returned the face for the randomizer, and since we don't know anything about this abstract randomizer and what its face values should be, we left that also as abstract and therefore undefined. That brought us to our randomize method, and our randomize method, we could fill in some code based on some little information we have, which is we want to select a random number, a random side, based on how many sides we have. Now notice, of course, we're using a method that's undefined, and this would be a problem except that an abstract class is never actually made concrete. It's never instantiated, and therefore the fact that this code doesn't exist yet isn't a problem, because anytime we extend this class, that method will have to be defined. Nevertheless, we know that if we multiply the number of outcomes times a random number from the math.random library and add 1, that gives us a side up value, which we can then return with getCurrentValue. So now it came time to actually create a class that can be made concrete. So we created the polyhedral die class that extends the abstract randomizer class. That means that this class needs to only fill in methods that were left abstract by our abstract class. It also means that a polyhedral die is a randomizer because it implements the randomizer interface because it extends the abstract class which implements that interface. So a polyhedral die can be said to be an abstract randomizer and a randomizer. Those are both true statements. Now we have our actual methods that we have to define. We started off by saying we're going to create a default constructor for a polyhedral die. If I call the default constructor, then I want a 6-sided die, and I want that die to be randomized. Otherwise, I can call an overloaded constructor where I specify an integer value to set the number of sides, and then I want to randomize. So I created a private instance variable to keep track of how many sides this die has. And getPossibleOutcomes returns the number of sides. So now, when I randomize this die, notice that randomize isn't listed here, but it is inherited from my abstract randomizer, and therefore I can use getPossibleOutcomes to return a random number between 1 and num sides. That left me with what other methods that I needed to define. A getCurrentFace, because notice getCurrentFace is also marked abstract. And therefore, if I'm going to extend the abstract class, I must create all the methods myself that are marked abstract. Well, all I want to do for my polyhedral die is take the integer value of my getCurrentValue and convert it to a string and return that. So that returns a string. And then I decided to also change the way the toString method works. And remember, the toString method is inherited from the object class, and all objects in Java are subclasses of the object class, and therefore they all have a toString method, which I am redefining so it prints a lowercase d, then the number of sides, then an equal sign, and then finally it gets the current face for that die and adds that to the string and returns all of that information. Next, we wanted to create a labeled die which could display different words on each side of the die. And we did that. Oops, that would be a labeled polyhedral die. I opened the wrong one here. That's a labeled polyhedral die, and so we did that by extending the polyhedral die class. That meant that we got all of the methods and functionality from the polyhedral die. It also means that a labeled polyhedral die is a polyhedral die and an abstract randomizer and a randomizer. So a labeled polyhedral die also is considered a randomizer. It's also an abstract randomizer, and it's a polyhedral die, as well as being, of course, a labeled polyhedral die. It has a big family tree at this point. A polyhedral die has an array of side labels, which we initialize if we create a default constructor for a labeled polyhedral die. Then we said the side labels should be 1 through 6. So we start by calling the superconstructor for our parent class, which is the polyhedral die. What does the default constructor do for a polyhedral die? It sets the default number of sides to 6, and then it randomizes the die. What's left to do? Well, we want to construct an array with the values 1 up to the possible number of outcomes, which we now know will be 6, and assign each of those to an array, the side labels array. Now, if we want to create a labeled polyhedral die with a different number of sides, we pass the constructor an array of strings, in which case we call the superconstructor for the polyhedral die, where we set the number of sides based on the length of the array. So if I give you an array with A, B, C, D in it, then I want a 4-sided die, and therefore I want a 4-sided polyhedral die, so I call the superconstructor, which calls setNumSides, and sets the number of sides here to that number, which would in my example be 4, and then it promptly randomizes that die based on the number of sides that I've just set. Next we go through the side labels array. We initialize the array as an empty string array, and then we fill it with each of our side labels. Next we overrode the getCurrentFace. Remember, we inherited get current face from polyhedral die. Well, what does get current face currently say to do? It says to return the numerical value for my get current value. But that's not what we want to do anymore. We want to change that behavior. So instead, we return the side label, and we want to convert the current value from a number between 1 and however many sides there are to 0 and however many sides there are minus 1. So we subtracted 1 from that value and used that as an index into our side labels array. Finally, we wanted to construct a new toString method where we tacked on a parentheses and the actual numeric value after we printed what the actual value of what the current face was of that string. So we called the super toString method, which means we called the polyhedral dies toString, which says d plus num sides equals get current face, and that called polyhedral die, or that left us back here with a string, and then we tacked on the end parentheses and get current value. And that is a short, approximately 10-minute tour of our classes as they currently exist.